Alrighty guys, here is Module 5 review, page number 1. So this problem here, we got Demon Drop at Cedar Point, Ohio. Crazy little theme park over there. Takes riders to the top, drops them 60 feet off the ground. By the way, that's where this plus 60 is coming from in this equation here. So a function that approximates this ride is this h of t equals this entire function. H of t is the height, t is the amount of time that has passed, and it simply asks how many seconds does it take for the riders to drop down to 0 feet. So because the height is what we're looking for to set equal to 0, that is what we will do. After that, a question like this, when the numbers are this large, my immediate go-to is the quadratic formula. So I'm just going to go right to it. So I got A is going to be equal to negative 16, B is equal to 64, and C is equal to 60. After I've done that, I just need to plug it right in. As a reminder, if you need it, that's negative B divided by 2A plus or minus the square root of B squared minus 4AC all over 2A. So just gotta plug and chug right in there. We got 64 divided by 2 times negative 16 plus or minus the square root of B squared minus 4AC all divided by 2A. Now, you could plug all of that into your calculator immediately. However, there is a little bit of simplification you can do beforehand that might make your life just a little bit easier in terms of typing things in. It's completely up to you how you want to go about this question from here, but I'm going to go ahead and do some simplifying first. So, for instance, I'm noticing that this 2 times negative 16 is negative 32. 64 over negative 32 is negative 2, plus or minus. I have no idea what 64 squared is, so I'm going to go ahead and go right to the calculator. 64 squared would be 4,096. So we got 4,096 at the start of the square root there. And then I'm going to go ahead and plug it in my calculator. Negative 4 multiplied by negative 16 multiplied by 60. And that's going to give me plus 3840, all divided by the same negative 32. Doing one more step before I actually plug the whole thing into my calculator, I got negative 2 plus or minus the square root of this guy. Oh, it is so hard to see this calculator here. I wonder if I just move it. Oh, it's so much better. So much better. So, move this around over here a little bit. Okay. So now I'm just going to go ahead, I get the square root of 4,096 plus 3840, and that's going to give me 89, and I'm dividing that by negative 32. So you got plus or minus negative 2.78388. Just double check I've actually done all those little numbers right there. So we got 64 divided by 2 times negative 16. That is definitely negative 2. After that, I squared 64. I multiplied 4 by 16 by 60. That's 3840. I added those up, took the square root, divided by negative 32, and got those two guys. So now I just got to do two different answers here. I'm going to do one that is negative 2 plus that answer, 2.78388. And then another one here, I'm going to go up because I'm running out of room in my paper, negative 2 minus 2.78388. So I have two answers here. I'm going all the way over here for my final answers. I have that number there. That one's negative, so negative 2 plus this answer. And that's going to give me negative 4.78388. I also have negative 2 minus that answer. So I also get 0.78388. So you get these two different answers. Hopefully it's obvious too that it doesn't take negative time for these writers to drop down. So the time, in fact, must be 0.78388 seconds. That is a quick drop of 60 feet. You are flying into the ground there. Okay, so we have a player bumps a volleyball. Function that determines the height of the volleyball above the ground in feet in terms of the number of seconds that have passed since she bumped into the ball is given below. So basically what these number means is she bumped into the ball about 4 feet off the ground. That guy actually is gravity, and that's actually how quickly she hit the ball, if you want to know some physics there. The height of the volleyball net is 7.3 feet. After how many seconds will the ball be high enough to clear the net? Effectively, what they want you to do is to make this 7.3 equal to h of t. After that, we're going to have 0 equals negative 16t squared plus 20t. Now we got to subtract over there, and we get negative 3.3. In this question, you're now going to do exactly the same thing we did up here. The quadratic formula, plug stuff in. I am not going to take the time to do that right now. Have fun. T is some dumb number. Okay, great. Height of the ball when it is bumped. Actually, I just mentioned that, funny enough. That's that 4 right there, so 4 feet. Another way of thinking about it, instead of just noticing that, is you could simply say h of 0, because that's when time is 0. That's the moment in time that it was bumped, and that's going to be negative 16 times 0 squared plus 20 times 0 plus 4. So h of 0 is 4. Either way, get that 4 feet. What is the greatest distance the volleyball will reach from the ground? Remember, you're hitting a ball. Ball's going up like this. It's going to be that top point up there. We call that top point our vertex. Vertex occurs at the axis of symmetry. So the axis of symmetry, now let's start using the formula we've been using in class. X equals negative b divided by 2a. So because x equals is negative b divided by 2a, in this problem we're going to have negative 20 divided by 2 multiplied by negative 16. And that's going to be negative 20 over negative 32. In my calculator, that's going to be 20 divided by 32, which is 0.625. So that is the amount of time it's going to take. That is not the actual greatest distance. So now I need to take this 0.625 and plug it into my function. So I got h of 0.625, and that's going to be equal to, and let's just do this whole thing on the calculator because I am not going to be taking the time to do it right now. I think the easiest way is actually to plug it in over here in the y equals. So I hit the y equals button, and then we got negative 16x squared plus 20x plus 4, and I hit the graph button, see what shows up. Okay, great. Now I got to plug in 0.625, so I hit trace, 0.625, and I hit enter. Oh, it's hard to see the calculator again. Oh boy. Might have to do that again for people. I don't know. 10.25 is the number of feet above the ground there. It's going to be, because that's that coordinate right there, 0.625, comma, 10.25. Easy enough. In the function 8, the initial velocity was 20 feet per second. Hey, I mentioned that too. How much higher would the ball go if the velocity was 32 feet per second instead? So if that was 32 instead, we would have h of t equals negative 16t squared plus 32t plus 4. That would be a different function, so I actually have to go back over here to my calculator and change that 20 into a 32. Go ahead and graph it again. I also need to figure out a new b value, or new vertex value. I already figured out the new b value. So the new vertex is going to be 32 divided by 2 times negative 16, which is 32 over negative 32, which is negative 1. Oh, negative. Oh boy. I'm like forgetting my own rules here. Positive 1. So we just go ahead and plug in 1 into this function, hit trace, hit 1, hit enter, and now we get a nice little h of 1 is equivalent to 20. So I got 20 feet. Not too bad. So there is page 1 all completed. Next video is going to be page 2.